For question number 17, the directions say to perform the operation and then simplify. Again, we're multiplying fractions, so the first thing we want to do is factor everything completely. The first numerator is a difference of squares. That'll factor as y plus z times y minus z. The denominator just stays as y plus z. For the second fraction, we have a numerator of y, and then we can pull out the GCF of y to leave us with y times the quantity y minus z. Once we've done that, we're going to try to cancel all of the common factors. For example, there's a y plus z on top and bottom of the first fraction, so those cancel. We also have a y minus z on top and a y minus z on the bottom, so those cancel. And then lastly, if we notice, there's a y and a y, so everything is canceling here. And when things cancel like that, they cancel multiplicatively as 1. It's the same thing as saying how many times does y go into y? Well, it cancels as 1. So our final answer would just be 1 over 1, which is just 1. Let's take a look at the next one. Here we have a division problem. In order to divide, we first want to rewrite it as multiplication. Some people would like to use the expression keep, change, flip to memorize this. The first fraction stays the same. The second changes from division to multiplication by taking the second fraction and flipping it upside down, like this. Now that we have a multiplication, we want to try to factor our numerators and denominators. I can factor a GCF of 15 out of the first one. That'll leave us with x minus 1 over 7 times, for the denominator on the second fraction, we can factor out a 5. That'll leave us with x minus 1. And now let's see what we can reduce. The x minus 1's cancel. I know that 5 can go into itself once, and it goes into 15 3 times. And then here, both of these share a common factor of 7. 7 goes into itself once. 7 goes into 42 6 times. Once we're done reducing, now we can multiply numerators and multiply denominators. I have 3 times 6, which is 18 in the numerator. In the denominator, I have 1 times 1, which is 1. So the final answer is 18 over 1, which would be just 18. Take a look at number 19. Now we want to go ahead and subtract fractions. One of the things you should recall is that whenever you want to add or subtract fractions, you have to have a common denominator. In order to find the common denominator, we want the denominators to be in factored form. There's nothing to do to factor the first denominator, but the second denominator looks like 9 times x plus 5. So if we look at these two denominators, the GCD here, we have to have a factor of 9, and we also have to have a factor of x plus 5, so that should be our GCD. So the goal is we want to write everything over 9 times x plus 5, 9 times x plus 5. The second fraction already had the GCD, so there's no need to do anything to that. But for the first fraction, if we're going from a denominator of x plus 5 to a denominator of 9 times x plus 5, we would need to multiply that denominator by 9. But whatever you do to the bottom, you also have to do to the top. So we're going to take the first fraction, multiply top and bottom by 9. That'll give us 18 over 9 times x plus 5. And now that we have the same denominator, we're allowed to go ahead and subtract the numerators. So the bottom will stay the same. 18 subtract 7 should give us 11. And that would be our final answer. Let's take a look at number 20. Again, we're asked to add fractions, so we need a common denominator. Here, the GCD, everything is factored. So we have to have a factor of x, and we also have to have a factor of x minus 6. So our GCD is going to be x times x minus 6. For the first fraction, I'm missing a factor of x minus 6, so I have to multiply top and bottom by x minus 6. So we're going to have a 2 times x minus 6 in the numerator. For the second fraction, it was missing a factor of x in the denominator to get to the GCD. So I have to multiply top and bottom by x. That'll give us 4x over x times x minus 6. I can simplify the numerators a little bit. This would be, 2x minus 12 over x times x minus 6 plus 4x over x times x minus 6. And now that we have the common denominator, we can go ahead and add the numerators. 2x minus 12 plus 4x would give us 6x minus 12. We should try to see whether or not if this thing will simplify. To do that, you would want to factor the numerator to see if there's any common factors it shares with the denominator. We could pull out a GCF of 6. That would leave us with an x minus 2. But unfortunately, there's no common factors here, so we can't break it down any more than what it is. That is our final answer. You could leave it like this, or it would even be okay to leave it as the 6x minus 12 divided by x times x minus 6, since there is no reducing. Let's take a look at one more operation type problem. Here we want to subtract these two rational expressions. Again, first things first, we're going to have to find the GCD, and in order to locate that, we have to have all the denominators in factored form. This denominator here factors as x plus 3 times x plus 6. The GCD between x plus 3 times x plus 6 and x plus 6 is going to be x plus 3 times x plus 6. Notice that the first fraction already had that denominator, so there's nothing we really need to do with this one. So it's going to stay the same. For the second fraction, it was missing a factor of x plus 3. So we have to multiply top and bottom by x plus 3. To get the common denominator. When you multiply x minus 4 times x plus 3, I'm going to skip a little bit of the algebra here, but remember, you'd have to FOIL that out and combine like terms. If you do that, that would leave you with an x squared. You'd have a positive 3x, and then a negative 4x would combine to give a negative x, and then the last term would be negative 4 times positive 3, which would be negative 12. Now that the denominators are the same, we can go ahead and subtract the numerators. Just be very careful on this step. Whenever you're subtracting that second numerator, that thing has multiple terms in it, so we have to make sure to subtract every single term. So this is going to look like x squared minus 6 minus x squared plus x, and then it's going to become a plus 12 all over x plus 3 times x plus 6. The x squareds are going to cancel because you have x squared and a negative x squared. We have a positive x, and then the negative 6 and the positive 12 will combine to give us a positive 6 up top, all over x plus 3 times x plus 6. And then lastly, we can reduce this because both of them have that common factor of x plus 6 in the numerator. So that will go into itself one time. So we're left with 1 over x plus 3.